Hi friends, in my last video I discussed the atmospheric refraction. In this video we have to discuss the twinkling of stars. The twinkling of stars is due to the atmospheric refraction of starlight and due to the changing in the position of the stars and the movement of the layers of the atmosphere. So, the light from the star is sometimes brighter and sometimes fainter, and it appears to twinkle. Why the stars are twinkling? Here it is due to the atmospheric refraction of starlight, and it is also due to the changing in the position of the stars, and whatever the atmospheric layers are there, the layers are momenting. So light from the stars is sometimes brighter and sometimes fainter, and it appears to twinkle. And one more thing we have to observe that whatever the planets are there, they are closer to the earth than the stars. Then the stars are far away from the earth and the planets are nearer to the earth. Then whatever the light coming from the stars are considered as a point charges, or point source of light, and the light from the planets are considered as a extended source of light. So the light from the planets are nullify the twinkling effect. And see here, this is the earth, and the light from the star is coming due to the different layers, and the next one, while coming from rarer to denser medium, the ray of light is changes. That's why the star appears twinkling. By this diagram we know that. And next concept is the advanced sunrise and delayed sunset. Suppose if the sunrise is 6:30 am in the morning, then he starts appearing only in 6:28. That is 2 minutes early he is arriving. That is called as a advanced sunrise. And what is meant by delayed sunset? The delayed sunset is if the sunset is at 6:30 p.m. and he will appears till 6:32. That is called as a delayed sunset. Then why this advanced sunrise and delayed sunset happens? The sun is visible to us about 2 minutes before the sunrise and about 2 minutes after the sunset. This happens due to the atmospheric refraction. Why this is happens? The apparent flattening of the sun's disk at sunrise and at the sunset is also due to atmospheric refraction. Then see this diagram. This is the earth and the observer is here, and observer this side and this side there is a horizon, and the right side is a sunrise and left side is a sunset. Then first we have to observe the sunrise. Then the real position of the sun is here. Then when the sun rays are coming from rarer to denser medium, it bends towards the normal, and if we extended this normal, then the sun is appears here, and this is called as a apparent position. That's why the 2 minutes before he is appears to us. And if you see the sunset, actually the real position of the sun is here. Then when the sun rays are coming nearer to the observer from rarer to denser medium, that light is bends, and if bending is extended, then the appears here. That is the apparent position. Then if the sun is set, then after sunset the 2 minutes also he will appear to us. This is due to the refraction. That is, from rarer to denser medium, the ray of light bends towards the normal, and if you bend that whatever the bending is there, if you extend that one, then appears at the top. That's why it is called as a advanced sunrise and delayed sunset. This is also due to the atmospheric refraction. Then the next is scattering of light. In the 9th standard, is matter around the sphere? On that chapter you studied this one, that is the scattering of light. In that, the one effect is appears. That effect is called as a Tyndall effect. The name of the scientist Tyndall observed this effect. That's why it is called as a Tyndall effect. And what is meant by Tyndall effect? When a beam of light is passed through to the colloidal solution, then the path of the light becomes visible. That is due to the scattering of light and presence of colloidal particles in the solution. This is known as a Tyndall effect. What is meant by Tyndall effect? When a beam of light passes through the colloidal solution, the path of the light becomes visible due to the scattering of light by the colloidal particles. This is known as a Tyndall effects. And why these colloidal particles appear? From where these colloidal particles appear? In the atmosphere. In the Earth's atmosphere, it consists air molecules, water droplets, dust particles, and smoke, etc. These all are there. And when the sunlight passes through the atmosphere, then the path of the light becomes visible due to the scattering of light by these all particles, that is air molecules, water droplets, dust, smoke, etc. Then the color of the scattered light depends upon the size of the scattering particles. Whatever the particles are reason for the scattering, then the color also depends upon the size of the particles. If the particles are very fine, then they scatter only blue light. If the larger particles are there, then they scatter different color of the light. This is about the scattering of light. Dear students, please subscribe this video, this channel, and share, like, subscribe for your maximum friends. Then only you can observe the latest updation of your syllabus, and the next concept you can get immediately. Then these are all example. When in the second beaker test tube, you can observe the beam of light scatters. Then in first, the beam of light is appears. This is due to the Tyndall effect. And in the dense forest, then the light coming like this. This is also Tyndall effect. Then these are all other examples. And last one, why is the color of the clear sky blue? Whatever the sky is there, clear sky, why that sky color appears blue? We have to see the reason. Whatever the fine particles are there in the atmosphere, they have size smaller than the wavelength of visible light. Whatever the visible light wavelength is there, compared to that one, the fine particles have the size smaller than the wavelength of the visible light. Then they can scatter only the blue light. Sorry. And they scatter only blue light, and which has shorter wavelength than the red light, which has a longer wavelength. When the sunlight passes through the atmosphere, whatever the fine particles are there in the atmosphere, they scatter the blue color more strongly than the red, and so the sky appears blue. Once, if the earth had no atmosphere, then there would not be any scattering of light, and the sky would appear dark. And the sky appears dark at every very high altitudes. This reason the clear sky color appears blue to us. And this completes your the human eye and colorful word chapter. Dear friends, if you have any queries, please comment my videos, and for the latest videos you can like this channel and share to your friends. Thank you.